Okay, good day, like minds. Once again, it's me, Marine Daddy, your regular TD tutor. Today we're going to be learning TD, and our center of attention for today's video is sectioning. I know this is not a new word to us. We must have had it when we are learning isometric drawing, orthographic projection, and related courses like that. So, today we're going to pay much attention into the word sectioning and what it entails. Section is very, very easy topic, but that's only if you get the rules binding it, you understand? So by the grace of God, at the end of today's topic, we are going to have a full knowledge and how to address questions that are related to sectioning. So as you listen and pay attention, we ask that God will give you the perfect direction and retentive memory in Jesus' name. Amen. So what is sectioning? The word sectioning. Uh, I'll define it to be, or I'll say sectioning or sectional drawing as we know it to be. They are multi-viewed technical drawing that contains special view of a part or parts of a diagram, a drawing actually, which reveals the interior features of that diagram, reviews the interior features, the internal aspect of the diagram. You understand? That's what section is all about. I'm having this diagram, right? If you notice, you realize that we have some interior aspects, things like the hollow part here. We also have this part which bulged in. This one, a kind of is it, should I say, an entrance from this part to this side easily, right? So sectional drawing has to do with displaying or addressing the interior part of the diagram, the contents of what that diagram is. Let's see this other one. So this is, I think this is a block, right? I just did a little sketch on it. Uh, this is the block. Looking at it from outside, we will not really know the content, the actual size of this, right? But with the help of sectioning, we'll have a clear knowledge of what the inside is all about, the nature of the inside. Do you understand? So that's what sectioning is all about. And we have different types of sectioning. There are so many. I think I can recall about 6 to 7 of them, but they are very, very much. But today, and for the sake of Federal University of Petroleum Resources 200 level engineering students, I will be focusing my attention on just the full sectioning because that's what the second semester pays more attention to. So I'll do the same so we're not going to get deviated. You understand? So just follow me right into it. But for the sake of learning and knowledge, let me just run through the different types as I can remember. We have the full sectioning, we have the half sectioning, we have aligned sectioning, we have offset sectioning, we have broken sectioning, we have ribs and web sectioning, we have revolve sectioning, and lots lots of them. You understand? But like I said, we'll just pay attention to full sectioning. So for the word full sectioning, it's very, very easy and very common. You understand? I think it's the most common of them all because it has to do with dividing your given diagram into two equal parts. Most of the time it's following a particular pattern or lane, you understand, according to the the um the part of the diagram in questions that needs to be identified properly. You understand? So this is just an isometric drawing. You understand? It's not a sectional question. It's going to be a sectional question if those signs and elements relating to sectioning it's applied on it, then you can be able to identify it ahead that it's a sectional question. But this is just an isometric. So, but for the uh full sectioning, it requires you to take off the diagram according to the direction that is required of you to take off. So once you take it off, the nature of the surface you find after taking off the part that is required of you, the full representation of that surface that will be left is what is known as full sectioning. You're not leaving any part behind. You are drawing and constructing it completely. That's what full sectioning is all about. So right now we now know what sectioning is about, and as well as the full sectioning that I said we'll pay attention to. So right now we are going to look at the rules and regulation binding sectioning, as well as the symbols that you need to see for you to identify a sectional question. Then when attempting a sectional questions, you need to observe the direction, the point of view or perspective of the viewer, as well as the part that is required of you to represent. You understand? And those are the things that we are going to focus on right now. Now there are about 4 to 5 of them, so let's pick them one after the other. The first one is what we call an imaginary line. An imaginary line looks like this: one, then a little dash, a longer one, a little one, and so on and so forth. Now, some of you might think this is a broken line. Broken line looks like this: just equal length, you understand, across the dashes, you understand. Now the difference between these two is that this is a broken line used to represent hidden part of a diagram. This is used to represent hidden part of a diagram that cannot be seen at a point of view or a point of reference. You understand? This is what is used to represent those parts of the drawing that is hidden. We mostly use this in orthographic progression. You understand? Orthographic projection, first angle and third angle. But for this imaginary line is used to represent a cutting plane, a sectional pattern, a sectional movement. You understand? A cut running or passing through a particular diagram. That is what broken line, or that's what imaginary line is used for. You understand? So this is what you'll be seeing often when dealing with sectioning or sectional questions. Now, how do you represent them, or how are they being represented in a diagram? So let's look at this now. For this diagram, when you see something like this, it tells you that, oh, there is a cut through this diagram. You understand? Equally, when you see something like this, you know it's passing through the diagram equally. When you see something like this, then you also carry a letter. So I like using S. Maybe na because I don't too do calculus, but anyhow, I don't know why X is very common. So you see it in this direction. So in your question, in word or written word, it will be like this: X this, X to S, stating that this is a cutting plane, an imaginary line passing through this diagram from S to S. You understand? So when you see this, it's already telling you that, okay, this is a sectional question. Yeah, it's looking like this. There's an imaginary line passing through this. That means then use cutlass, they cut this thing into half. Now, like I said earlier when I was explaining what sectioning is all about, I made it to understand that sectioning has to do with chopping off or cutting off a particular diagram so as to identify the content, what is hidden to be seen. You understand? So this is one of the things you need to know. Okay, so like I said, this is the imaginary line, right? Now, this imaginary line, when it's cutting, remember I said it's also serve as a cutting plane, cutting the diagram into equal parts, right? So I'm holding my knife. the knife dey cut this thing in this direction just as I drew. So you go cut this one down to this bottom. See this line means say you go cut am also fall down, right, to this part, right? So I'll fill it up like this with my imaginary line. I'm just trying to give you a clear understanding of what's in it. Understand? You understand? So meaning that this line you are seeing moving in this direction, it's like the cutting plane, the knife, the movement of the knife down, movement of the knife down. So it's going to cut through this part, right? So the content of what is now remaining or left at this part is what is known as the full section in the full representation. Now, aside this imaginary line, there's what we call points of reference, or you say perspective, point of perspective. It means that there is a direction that the viewer is seeing the diagram from. You understand? And is usually represented by an arrow in this manner. So whenever you see an arrow like this, the arrow usually accompanied by a particular letter. So let's say it was Precious that was looking at this diagram. So we'll name it P as Precious, P for Precious, right? So it means that Precious is looking at this diagram from this point of view, this diagram, from this point of view. The only thing Precious can see actually is just this surface, this part of the diagram. You understand? As well as, okay, there will be nothing at this side, right? So you just see whatever is left at this other part of the diagram. Then this and this. She will not know the content of the diagram, right? So, like I said earlier on, that is the advantage or the needs why we study section, so we can be able to tell the content of the diagram. You understand? Yeah. Precious can also view this diagram from this part. But if she views it from this part, she will only see this square-like part. Okay, this is a parallelogram, right? So she'll be able to only see this part, this surface. She won't know the content of this part as well as the depth of this side and also this, right? So once again, that's the reason why we study this section, right? Yeah. Another thing again, aside from this and this, another thing you need to pay attention to, which is the rules and regulation, it's the wing. There's what we call wing in isometric drawing, but I'll look for an example that carries a wing, so we'll pay attention to it and learn it. You understand? Now there are other rules again that we need to follow. Let me give us a little scenario. Okay, so Precious went to the market to buy food stuff so she can prepare food and eat. And also store some in the fridge. On her way going, she realized that before the food go done, hungry go don kill me o. Ma check whether I go buy um donut. Yes. So she decided to stop by and get herself a donut. So this is the donut Precious bought for herself. Una no mind me o, na like this donut be o. I no know about una. Only God know where una dey chop una donut from. This is how my donut looks like. So this is Precious donut, what she bought. So as she was about to eat it, Favor came around, one of her friends that like beggy, and then was Favor. No vex if your name na Favor. So Favor came around, I was like, please, I've not eaten for like 5 days. Please come and give me this. Let me just eat. I'll be okay. Please. Do you want your friend to die? That kind of thing. So Precious decided to like give her to take a bite, just small, make she collect small. Then Favor was like, thank you very much. So Favor decided to take a bite and she ate it like this. Yeah. Based on what I said earlier on, one of our rules or identification of sectioning, this is what we know, or is also known as what? also known as imaginary line. I hope people got it. It is known as an imaginary line. So it's the imaginary line that I was talking about. So this is the imaginary line, chopping off the thing, taking a bite, a cut out of the initial diagram. So Favor decided to take a bite, and what will be left of this stuff should be some looking like this. What should be left of this stuff should be looking like this. Something like this. I'm sure it should be looking like this. Should be looking like this, right? So after taking off this part from the diagram, so this is what will be left. Now, I'm trying to explain the third rules, you understand? Now, the third rule of sectioning states that any part that is affected by the imaginary line, any part that is affected by the cutting plane, it's going to be looking rough. The surface of that part should be rough. And since it's going to be rough, we are going to represent it by diagonal lines. Diagonal lines. Now, this is what diagonal line means. For those of you that don't know what diagonal means. Normally, the surface is supposed to be looking rough, abi? But it's obvious that we cannot produce something like this and give it to an examiner or a marker to mark for you. They will give you bad. So this is the proper way of identifying it. Yeah. Now, the part that will not be affected or that is not affected by the imaginary line, the cutting plane, will be plain, just blank, empty, clean. You understand? Now let me give you another example. You are asked to put 3 maggi inside your beans. After putting it and testing, you realize that the maggi did not catch it very well. They were. So you decided to like put half of a cube. So you took a pinch out of the cube. This is my cube. This is how my cubes look like. Abi? So I decided to take off half out of it, just a pinch. So it's going to be looking like this at the end after I take off that part. It's looking like this. Right? It will look like this, and this side will be rough, unlike when it was just smooth. Yeah. So this part, like I said earlier on, is going to be represented by a diagonal line. Abi? Now, sometimes the cut will not pass through that diagram completely. There will be some hollow part that the cut will not be affected. Those hollow parts will be represented by a blank surface, just as this one. See Precious, Favor teeth rather. It's obvious that her teeth will not get to this part, except say Favor get big teeth, sha. But let's assume that Favor is a normal human being wey we know, no be dragon. So her teeth will not get to this part, just this side. So you realize that this part will be rough, but this side will remain smooth, right? So that is the third rule you need to know about what section is all about. The part affected by the cut is going to be represented by a diagonal line, you understand? And the part that is not affected will be smooth. Also, those diagonal lines, the distance between each of them will be equal. Not that diagonal line, you now start doing something like this, 1, 2, then next one be like this. This is a work of a madman, you understand? So this is the proper way of identifying it, you understand? This is the proper way. This is wrong, this is wrong. So that is the third rule. Another rule you need to put to consideration is the arrangement, or should I say the positioning of a sectional view. Now, we know that this is an isometric drawing, right? This is an isometric drawing. Why do I know it's an isometric drawing? Because isometric drawing is a kind of drawing which is drawn at an angle of 30 degrees to the horizontal. 30 degrees to the horizontal. But for sectional drawing, it is drawn at an angle of 0 degree to the horizontal. 0 degree to the horizontal. Meaning that this diagram, if I were to identify this thing in a sectional pattern, it's supposed to be laying flat like this. meaning I will not be able to see what is at this side and what is at this side, as well as this part. The reason why we present diagram in 30-degree for isometric drawing is so we can be able to see the front view, the side view, and the top view. But sectioning, you don't have that privilege, right? Because it's just balance 0 degree. Now, back to what I was trying to explain. Now, the positioning of a sectional view, it's 0 degree. Now, this is my diagram. I was trying to explain a Maggie cube, right? Using this, right? So when I take a pinch out of it, I was now having this rough surface. Initially, I'm supposed to present it like this, but sectional view said initially it's supposed to be presented like this, right? But sectional view said that no, it should be balanced, stay flat on the floor. It's supposed to be like this since this is looking like this, just at an angle. But the rule says it should be flat, just like this, 0 degree, and balanced like this. You understand? So that's the rule. Another rule again you need to put consideration is broken lines. You don't use broken lines in sectioning. You only use it in orthographic projection. You don't use it in sectioning. Remember, in our what I was trying to explain previously when I brought up imaginary line to consideration, I said that broken lines are used to show hidden details of a diagram. But sectioning is contradicting it, right? Because sectioning is revealing the hidden details, right? So why will you reveal hidden details and still put a broken details to it? You understand? So which means that you don't use broken lines for sectioning, except in some rare cases where the question will ask you to draw a particular view in orthographic projection stating the sectional view. No worry, we go reach that level. Una chill, calm down, small 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 small, we go get there. So I think I've explained uh the major signs as well as the rule. Remember I told you about wing. Wing is also another thing you need to put to consideration. Wing is always looking like this. Whenever you see wing, you don't section it. I'll look for question that carries wing, then I'll show you how to attack the question. Okay, we are going to do this work. Definitely we'll be doing it, but before we do this, let's start with a very easy question to attempt. So blank page. Now I'm having this diagram. Whose diagram is this? Anything you call it is the diagram, but now this is an isometric sha. So the isometric is having a hollow part in the diagram. Now, like I said, Precious, okay, the sectioning. Precious was looking at this diagram from this part. Let me start with it. Precious looking at this diagram from this part. This is letter P. P for Paul. Sorry, P for Precious. So Precious looking at this diagram from this side. She can only see this side, but her as supervisor told her, no, there's something hidden inside and you need to see it. Tell me what is inside that place. You need to see it. So with the help of sectioning, the diagram is presented in this format. Okay. Then it will pass through, right? So we have this x, right? So stating that the diagram is going to be chopped off from this side, right, from this direction, and players will now view the content of the surface here. So based on everything I've been explaining since, please, people of God, let's use our church mind and remember everything I said. If you take off these parts from this diagram, what will Precious see? Precious will see this part of the diagram. Ew, I sabi draw. So she'll be seeing these parts. She'll be seeing this part of the drawing. Remember I said the cutting plane, whenever it's the whenever the cutting plane affect a particular part of the diagram, it's going to be we are going to present that part with a diagonal line stating that there has been tampered with, is now rough. But a part that is not affected, it will be plain. Now, based on what I said earlier on, this knife go cut through this part, abi also cut this side, because here is thick place, the thickness of the walls, right? This thickness, this is the part here that the stuff is passing through. So it's supposed to be looking like this. This side, the thing no reach this side, right? Because here na hollow place, so the knife no go pass through this other side, right? So here will remain blank. But this side to be affected, making here also a rough surface. But like I said earlier on, this is not the right way of representing a section, right? So the right way will now be in this manner. The total length of what you have from here to here, here to here, here to here, the total length will now give you a straight line, because you are viewing it from here. Since you are viewing it from here, everything here will just remain straight, right? Because it's no longer at an angle. So it will look like this, as well as the height. Then this here to here will give you the length here. Here to here give you the length here. So at the end, here will now be represented diagonal. Most times the diagonal lines, the distance across the diagonal line is 0.2. But people of God, don't start measuring 0.2, 0.2. You can measure the first one, then use your eye gauge. During your first semester, I taught you how to make use of eye gauge. Use your eye gauge to identify equal distance and apply them. You understand? So this is the right way, this is the wrong way. You understand? But this is how Priya is going to see this side, because you have taken off this part of it. I think this one is simple, abi. Let's look at something that is more complex. Okay, let's look at this cutting, the cutting plane in another direction. Instead of this part, the cutting plane is now moving like this. The cutting plane is now moving like so. Let's say here is y and here is y. And let's say favor now view this thing from this direction. What do you think favor is going to see? Yeah, I know some of you are saying now the same thing now actually is the same thing, right? So from this direction, favor will be seeing something like this. Favor will be seeing something like this. So this is what favor will be seeing. This side. So it's actually the same thing. So when you present it in a section now view, it will be looking like this. So if you thought of this before I drew it, I'm happy you are following up. So it will be the same thing, because the nature of the diagram is the same. Now what if the diagram now, it's now sectioned in this direction? We are playing with this stuff. I just want you to get comfortable with sectional question. Let's say this is Z. This direction is direction of Z. After cutting it like this, they now told General Kostrep to take off this part that has been divided off this place and state the nature of this. Okay, you can pause your video and draw it, then play it, so you know what I did at the end, right? So when you do this, you'll be having this. This is what General Kostrep will be saying. Who is your General Kostrep? I think it's Charlie, right? That handsome boy. Charlie, no allow your head big good so much. So Charlie will be seeing this like this, right? Because you don't take off this part. But like I said earlier on, in sectioning, this is how you represent it. The cut no go pass through this side. So I think with the knowledge from this, we can attempt this big one. Shebi? We are going to be attempting this question. I know when I started this video and you guys saw this one, you're like, this one go hard though. But I'm very sure that some of you now looking at this, you can make attempt a very good one. So let me walk you through. Yeah. So what I normally advise or tell my students is, whenever I will get to an example or a classwork, you can pause the video, make attempt, then watch the video to see if your attempt and what I did is correct, if they tally. You understand? It also help, it give you a sound mind, and a right approach and confidence to attempt question. Now Precious is looking at this diagram, abi this isometric from this part. She cannot see other part, just this side. But the supervisor was like, Pius, there's something inside this thing. You need to see it. You're an engineer. Engineer have to look at every angle of the thing. Pius like, how will I not do it? The supervisor was not like, okay, let me section this thing for you. Let me give you a cutting plane. So the guy did this. The supervisor did this and asked her to identify the nature of the other parts of the diagram. So this is what I would do if I were to be Precious. Please follow my approach. My approach is the best. Please, any other person's approach might be best for them, but to me, and if you believe in me, follow my own approach. Thank you. This is what I'll do. The height from here to here is how many? 45. Shebi? I'll draw 45. This other part I can see here to here, abi? I will draw the first thing I can see. If I were to be Precious, I will draw the first thing I can see. Then later, I will start working on the part that I cannot see. So for now, I can see the total length from here to here, which is 45. I will draw 45. I can see from here to here, which is how many? Still 45, right? So 45, then the total 90. Abi? Now, from here to here, the total is how many? 10, 10, 10. That's 30. Here is how many? 10, 10, 10, 30. Then the depth is how many? It was not given, abi, but if we do our calculations, you realize that the depth will be when you subtract this from the total. So 10 subtracted from 45, you'll be having 35. So the depth will be 35. This is what Precious can see first, just this. But that's not enough. The question was, look, identify the nature of the surface you get when you cut off this. That simply means that if you cut off this, you will see this place. Abi, here to here, you'll be able to see it. The total distance from here to here is how many? 10. Well, you'll be able to see it. The total distance from here to here, you'll be able to see it, which is 10, right? So this 10 now, you measure 10 from here to here. 10. Now this thing, this is my 10. Then I'll be able to see this side. When I cut this thing, I'll be able to see this wall, right? The distance from here to here, I should be able to see. That's 10. So I'll measure 10. Then the one to this side is also 10. This is a hollow part, so which means that I will see the total depth of this thing. This is my total depth. I should be able to see the total depth, right? Now, after this part we are done, then for this side there's nothing here actually, right? So we'll leave this side empty. Now this other part, cutting through downward, you realize that you will be able to see when you cut off this side off, you'll be able to see this other side of the diagram here. You'll be able to see it, which is this. Then down to somewhere around here, you will now see this side again. You see this side of the diagram again. Yeah, just follow me. So when you chop this thing off, you see this part. It has a depth, which is 15. So that 15 now, you'll be able to see it. So looking at it from here, since we are using 0 degree to the horizontal, everything will just remain flat and not at an angle. To be flat. So meaning that this side and here will blend in. So you have something like this. So once you are done with this, what is left for you to do now is to identify the rough surface and the smooth surface, the place affected by the cuts, the imaginary line, and part that is not affected by the imaginary line. So let's go. This side will be affected, right? Making the surface thick, right? Rough. So on rough surface, you use diagonal lines. This other part, will it be affected? Yes. This side too will be affected. Now I want to ask you a question. When this thing cuts down, You know that it's dividing this thing completely into two different parts. This other part of the diagram, that's this side, will it be affected or it will not be affected? It's obviously going to be affected, right? Now over to this side. This thing is cutting through. E go touch this wall or e no go touch this wall? It's obviously not going to touch, right? Look at the direction. When it falls down, it will cut through this part. So it will not touch here, but it will touch this surface, abi, which is here to here. That's here to here, to touch this place, as well as the other part of this side, looking like this. So this is view from Precious. We are going to do a proper construction, but the first thing you need to do whenever you are giving questions like this, start with a rough sketch first, then later you use your ruler to do a proper diagram. Now let's give ourselves another question. What if we divide this thing from the middle here? What if we divide this thing from this middle? This middle means that the total from here to here is 90. So the middle here will be how many? 45, abi? So we are cutting through from 45. So let me draw this. So let's assume that this is another question. Let's assume that this is another question. So it will cut through. So be having this diagram. So let's say this is diagram Y. So that other part moving out, you have another Y, right? So from YY. So this diagram now, let's assume that Favor is looking at this diagram from this part. Let's assume that Favor is looking at this diagram from this part. What do you think Favor can see? If you take up this part, normally, let's start with the things Favor can see. You know, that is how I taught you, and that's how I want you to be doing it. First, Favor can see this part, which is this. But when I now take up this part completely, what can Favor see then? She'll see this other part. But the total height from here to here is equal to total height from here to here, meaning that the height will remain. What about the length from here to here? It will still be the same, meaning that the length will also remain. Now, chopping this part off from this diagram, you'll be left with only this side. So what is the surface I can see? I will then be able to see from here to here, which is 15. So here to here, 15. There is nothing at this side. I will not be able to say there's nothing at this side actually. But from here to here to this other end, that's this other end, I can see 15, which is 15 here, right? Since here there's nothing here, I'll clean off this side. I'll clean off that part, leaving just here and here. Now, it will be having a depth of how many? 15, right? So 15 here, 15 here. Then I'll be able to see this side to close it. Also, I will see this side of the diagram, down to this part again. Since here is off, I'll be able to see it down to this part, and that part round through completely. Then when I take off this part, I will see the rough edges of this place because it will be affected by the cuts, right? Okay, I've even given you a expo. So let's see. This part, will the knife affect this side of the diagram? Obviously not, right? So here will remain clean. But will it affect this part of the diagram? To affect it. And where is this part in this place? This side. So here will be looking like this. So this is Favor's view. We'll work on that. We'll apply the whole measurement, the length, the dimensions. So let's see. What if we are given just this part of the diagram from the half of this side? Here to here is 30. So half of it will be 15. So we are working from the 15. From the 15. We are working from the 15. So let's say this one is Z. And we are now okay. They then ask, let me use a guy's name now, Daniel. They now ask Daniel, Daniel, look at this diagram. Look at the diagram from this place. So what can Daniel see actually when he's working with Z? They ask him to look at the cutting plane ZZ. So what can Daniel see? Means that Daniel have to just take up this part of the diagram and identify the surface of what is there. So we want to work on Daniel's own. So for Daniel's own, this is what Daniel is going to be saying. Remember, I told you guys, first identify the parts he can see normally. Then after supervisor gives him his cutting plane, you will now identify what is there. So when you take off this part, you'll be able to see the total height from here to here is going to be equal to the one here at the other surface, right? Please, sometimes the height of the outer surface and the inner surface, sometimes they are not always the same. So you need to identify it correctly so you will know. Men looking at it with your spiritual eyes, okay, not spiritual eyes, like engineering eyes. You guys are engineers inclined, so learn to think like them. So looking at it, you should be able to identify if it's the same or not. One of the easiest way to know is through your dimension. That is why dimension is always important in any thing you are doing. So this is the surface. Since this is the surface, after taking off this part, what can you see? You can then see this part here to here, looking like this. You'll be able to see this side too, Abi. You'll be able to see this surface. And the length from here to here is how many? 20. You're able to see 20. Then the other end. This is hollow part, meaning to go down. Sometimes hollow don't go down. No. If you want the hollow to stop at any part, you have to identify. But from your question, sometimes they'll tell you how the hollow part should look like. So this is my diagram. This is what I'm going to see at the internal parts. Now, but you need to identify the rough edges and the smooth edges. The knife is going to affect, or the cutting plane is going to affect this side, because here is like the thickness, making here diagonal lines. This side, will it be affected? You have to think, and I don't know what is in your mind. But if you say the wrong thing and you assume it's the right thing, my God will judge you. So this is the surface and you cannot be able to see it because the cutting plane will pass through like this, so it will not affect this side, making it smooth, but it will affect the okay. This one is even looking like our previous example, right? So this is how it's going to look. So this is D. So let's assume now that this diagram was, we call this diagram from this side. Diagram was sectioned from this side. Now, what I'm doing is to make you feel comfortable with sectional questions. You understand? Because sometimes people get scared a lot. So want to work on the different possibilities. You understand? Different possibilities. So this thing was sectioned in this manner. So let's say this one is Z. This one is sectioned in imaginary line Z, right? And still from this view, I told my secretary divine. Okay, I told my secretary divine, so I've used the, let me not use divine again. My first secretary that abandoned me, so that's Lady V. So I'm using V now. So V is observing this thing from this angle, and they asked her to identify ZZ plane, ZZ cutting plane. So it means that this whole place will be off, remaining this little part. Now, what can she see? The first thing you need to do first is the first part she can see, which is this, right? Now, she can see this side. So, moving on to the part she cannot see after taking this cutting plane. You'll be able to see the height from here to here is going to be the same, right? Remember, I told you that you need to identify the height. You can use the dimensions to identify. Sometimes the dimensions might be tricky. You just need to understand it properly. So as time goes on, that will not be an issue for you. So take off this part. You see here to here, right? The height, the distance from here to here, which is 15. Then here to here 20, here to here 20, then here to here 15. So this is it. Now you can also agree with me that she can see this part and this part, and that's 15, right? So 15 down, 15 down. But people of God, this place that was blocking this side, will it still be there? No, obviously not going to be there. So I'll clean it off. Remember, this is the reason why you need to start with rough sketch first. So let's go. When I take this thing off, when I take it off now, yeah, now let's see something now. This is a trickish part. Thank God it appeared in this question. Now let's see. This diagram is looking like this, right? That's the total. Now you can agree with me that this side will be affected, this side will be affected. Let's say I put this thing here, right? Now let's see. This side is also going to be affected, right? Because there's no hollow part again. Remember, these hollow parts, we have identified it by cleaning off this side. So this side will be affected, making it thick. This other side, everything will just turn to a straight surface at this side. Like all this contour, all this gap, all these corners, it will no longer be visible at this side. Here will just be a smooth place. It's just like a cake. It just look like a cake. This is a cake. A cake having this pattern. A cake having this pattern. God help me. Now you now divide this cake. All these things are more like the icing sugar, right? So when you divide this part of the cake, you have a smooth surface. You understand? That's what is also happening here. That's also what is happening here. You have a smooth surface at this side. But when I mean smooth, I don't mean the surface. So the surface will be rough as usual. That's what I've been explaining. I mean this other part of the diagram will be off, making here just straight something, right? So since we are having something like that, that means that everything here is going to be smooth, a diagonal line. You understand? So that's Lady V zone. You wanna tell Lady V, say make you come resume in duty as secretary. Now I even need 3 secretaries. We have Divine and we have Lady V, and Nape need to join us. There's no even room for sacking. So let's go. From there, we have done 4. We have played it about 4 part of the diagram. So let's see a particular trickish part. Let's see. What if at this side I take off this diagram from here? What if I take off this diagram from here? I won't catch some people now. Pause your video and attempt this. Sorry. Okay. So this is it. Right? I won't catch some people. Let me know people that have been following up. My English what they manage speak. Man say people where they follow up. I can use another language. I can speak about 7 languages. But I want to stick with English for today. Maybe I'm not gonna tell me say I no be Igbo, I no be Yoruba. So let's say this one is I ma bring calculus enter. So this is I, and then I said Samuel should view it from this part. What can he see when you take off this part of the diagram? Anybody will get this thing, just DM me, message me, I will give you something. What can you see? I said pause your video and tell me just this part. You first thing you see this, right? Abi? you see this surface first. Then when you take off the sectional part out of it, you realize that this side will not be affected. This side will not, nothing here will be affected. Nothing in this whole diagram will be affected except the thickness direct. So this is just like the Maggi cube I was trying to explain that time. Where that Maggi cube, this Maggi cube I was trying to explain, making it looking like this. So in other words, our surface will just be like this with this total length and height. I think this is clear. So you on your own, you can play with every position, every direction, every point of this diagram, every side. You can play with them. You understand? To see if you can do better. Okay, I like doing this one. This one is really sweet. What if we cut it like this? The cutting plane moves in this direction. Jay, I just remember something now. Ma catch my students wey dey run me street. So this is give me a word, give me a letter. Okay, let's use J. Let's use J. So this is moving like this. So we have J. So from this J, they told, okay, this J meaning that this stuff was sliced like this and this whole part was taken off. What can you see looking at it from this place? I like giving the general culture the hardest work to do. So what can Charlie see from looking at this place? So this Charlie, Lady Charlie. So this is Charlie looking at this diagram from this top. What can he see? Now Charlie can actually see. Okay, first thing first, we need to look at what we can see, identify what we can see from the top. First, we can see this part of the diagram. So this part stays first. We can see this other part fully. This other part of the diagram, we can see it fully, making this side. That's the total length. Here to here, like this whole part is how many? 30, abi? Yeah, here to here is, this side is 50, I guess so. That's 50, 30. So we are trying to straighten it up. This side is 30, so another 30. Then this other part is how many? 30. We can see this side of the diagram fully. The full diagram. See, I'm just picking them piece by piece. I can also see, looking at this thing from, please, this arrow is not saying just here. It means that it's looking at it like the total surface of this diagram. Please, I cannot draw triangle arrow at this part to disrupt the initial diagram. Please, let's take note of that. So at this part, we are having full length of 20. So I have 20 like this, right? Then this last part. So this is what I can see normally. Now this thing na Charlie go fit see. That's if Charlie fit see am. So this is what he can actually see. Now, the supervisor has sectioned it using cutting plane in this pattern, cutting plane J. So that means you have to take off this part off. What can you see at this part? Let me see. Please, this stuff will also move like this. So I hope you guys know, because everything is going off. This J will come like this, take this side off, move like this, take this side off. You understand? So what can Charlie see? When you take this thing off, Charlie will be able to still see this side. But will this side be looking like this? Just like this. Remember, there's a hollow part here. Will I represent that hollow or not? Yeah, I will represent it. So the hollow will be here. All these good students will say, MD, don't forget this hollow. Yes, I'm happy if you correct me. Just be correcting me. Now you can see this side, right? So since you can be able to see this part, let's see. That means that we'll take off this part off. When we take off this part from the diagram, we're able to see this side will be affected, abi this whole thickness will be affected. So it will represent it using a what? A diagonal line. Now at this part, will this cut affect this part of the diagram? Yes or no? It will affect. It's going to affect. No, it will not actually affect. You understand? Please just follow this thing. The cutting plane did not touch this side, so making here blank. Now what about this side of the diagram? Will the cutting plane affect this side? Yes, to affect as well as every other place here. So making, when we cut through, this part will not be seen again. This whole part will not be seen. So we are cleaning it off. We are cleaning it off, making here looking like this. Making here looking like this. So this is how our diagram is going to be presented. You understand? So any question, you can always message me or call me on phone. As far as it has to do with CD, I'm always ready to help you. So this is Charlie's zone. There are several ways. See, you see section. Section is one question or one topic, one course in CD that you can derive countless questions from it. From one diagram, countless questions. From this same diagram, I can still give another cutting plane looking like this. Cutting plane looking like this. Looking like this. So this looking like this. So okay, please, you are going to pardon me. This our diagram is looking so confusing somehow, but please, this is what we are working on. Right, so we are working with cutting plane LOP 72, LOP 73. You can name it anything at all. So the cutting plane move down to this side, right? Remember, you will cut everything with crossing parts. Pass through everything that crosses its paths. So this is the cutting plane. Right? So this is the cutting plane LOP. Please, the advantage about this is that they will not give you too many stuffs to do. They'll just give you only one or two. Cannot pass two actually. But since this thing is it's for the sake of learning actually, that's why I'm just doing this thing. Several places that you can find it. Please, yeah. So we are working with LP, right? 72, LP 73. So this LP, that means we are taking it off at it from the top, right? We're taking it off from the top. So meaning that which person will I use now? Okay, let me use Chiemerim Marine 200 level course rep. I like trouble. Chiemerim, what is her second name, sef? Chukwuemeka, everything na Chi. So let's use CC. Chukwuemeka. So she's looking at this thing from the top. When you take off these parts of the diagram, the only thing left for her to see, let's try to identify it. Let's see. The first thing she will see, as usual, she will see these parts, just as what Charlie will see. Except both of them they see at all. We have done it before. This is what they will see normally. So let's go. Now, Charlie saw this there at the end. It was looking like this. So let's observe what this person will see. When you take off these parts, this side will be looking alike, just as Charlie's own. Okay, so let's move to this side. This cutting plane, did it affect this part or not? It did not. Just as Charlie zone did not affect here, so also this one did not affect this. So here will be plane. Here is going to be plane. What about this part of the diagram? This part of the diagram, let's see. Please just follow me. This part will be taken off, right? But there's still some extension left at this side. So when you take off this part, here will be looking like this. The cutting plane did not touch this side, this surface, because it just passed through like this, making here plane. While this one is going to be looking like this. One of my favorite topic is this sectioning. It's just so beautiful. Like it gives you opportunity to like pay attention to some facts. So having done that, this is what we are left with. This is our answers, right? This is our answer. This one belongs to who sef? Think S. That's S. So at the end, this is what we have. Now we have done the rough sketch. How do I present it? Is still the same thing, using your normal dimensions. All these things are your dimensions. Use it to construct your diagram, and that's all. So let's work on one or two of them. Then no, we're not necessarily going to do everything, just one or two. So let's see. Let's pick the one Precious did. So let's pick the one Precious did. So this is my diagram. So let's go. The total length of Precious own here to here is how many? Remember, Precious was looking at x. So x was the first one we did. So the first one was having total length of how many? 90. That's total length of from here to here, 90. So I'll come here, I'll do 90. So this is my 90 from here to here. Everything should be thick lines, no broken line, thick lines. Now I've done this one. height the height is how many? Here to here, 45 abi. The height is 45. So this one here to here, 45. So I'll measure 45. Please, when we started CD, I taught you guys how to use 8 and 10. Please remember to do that. I'll see if I can make another video to explain it just for it. Right. So from here to here is how many? Here to here in our work. That's this part of our diagram. That's this part of our diagram. Abi, remember that's what we did. This part of our diagram. Now this place. So the length is how many? 30. So I'll come here, measure 30. Measure 30 to this place. The depth from here to here is how many? 15. Remember, so it's 15. So I'll measure 15, 1.5. So this is my 15. This is my 15. Then I'll close it up. So I've done this part. The next thing again I need to do is the depth. Here to here is how many? In our question, here to here, remember I did the calculation. When you take off 10 out of this, 10 out of the total of 45, what will you be left with? 35. Some of us don't even know how to calculate. God will help us in Jesus' name. Amen. So I have 35 to this side. So on the other side, here to here is how many? From this our work, here to here is 30 as usual. So 30. The depth 35. then we close it up. Close it up. So I'm going to draw what Precious is going to see. Now, here to here, we need to know the distance. That's here to here. And the distance here to here is how many? 10. This other side to 10. So that's 10 at my right, 10 at my left. 10 at my right, 10 at my left. Goes down. Goes down. Down, 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 down. Down, 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 down. Down, 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 down. So at the end, we'll now identify our rough edges. Now, you do the first one. This is what you need to do. Yeah, please, let me even clear the air. This cutting plane is a diagonal line, and the angle usually used for this diagonal line is 45 degree. Angle 45 degree. Please take note of that. So all you have to do is to measure your angle 45. So let me bring out this. So for me, if I'm starting my work, angle 45. So this is angle 40. Let's say I'm working with this as my angle 45. Please, I assume most of us know how to balance our ruler. I'll still make a video sha. So the distance apart is supposed to be 0.2. So meaning that you measure 0.2, this 0.2 here, and you do this here. So this is my 0.2. So all I just have to do is to keep up with the distance using your eye gauge. Because if you start measuring 0.2, 0.2, everybody fit don submit go house, so result go come out sef. They will go for holiday, you still dey measure 0. You go still dey measure 0.2. So you just follow this pattern, follow it like that. Just follow the movement. Follow the movement. Follow the movement. As you can see, I'm not stopping, I'm just moving like that. Just moving. Whoever connects, I'll follow up. Make sure that it's neat and thick. Use clean pencil. Make sure you buy better eraser. They will have good quality eraser of 1,500, 2,000. Buy those ones. Don't buy Cinderella eraser. Here's the eraser that have Mickey Mouse. What is that? And you want to have A. So at the end, I've done my work. I'm very happy for myself. So I'll dimension. So here to here, put my dimension. Put the dimension. Remember, I told you dimension is very, very important too. Dimension is important too. Please, let's fill this up. Fill it up. We have what? 10 mm, 10 mm, 10 mm. We have how many here? Please, not necessary in millimeter sha. You can choose to convert to centimeter if you don't have small handwriting. The major things for it to be visible. So here to here, I think is 30. If it's not 30, Mona, go find out by yourself. I don't try. So here to here too is 30 millimeter. So next I want to do is to observe the height. The height at this place. Please, remember I was explaining distance apart in our first semester. Please, you can work with your ruler. Just observe this part of your ruler. I don't know if you can hear it. You can take the distance from here to here as this from here to here to work. Please, the major things for it to be equal at all parts or distance. So here to here is how many? I think it's 45 millimeter. And if you are using your dimension, make sure that everything should be in the same unit. This one now I don't say use centimeter. Sometimes you now use centimeter for the smaller part and use meter for the bigger part. No be mind that they teach you that one. No, I don't know who teach you that one. So you can come to this side, measure only. Okay, you can come here to here, measure, do your measurement. Do your measurement from here to here. I think, okay, we also have this at this side. So we have from here to here to be, how many set that is? 15, abi? So we have 15 mm. Here we have, here to here should be how many? 20 mm. I think this is it. So as simple as ABC, I'll be as simple as this. So that's still the same approach for this. This one, so they are easy. So just to get the center, using the distance here to here, and you walk. So this is what section is all about. There's no need doing this other parts now because it's still the same approach, and my end be no waste. But anyhow, let's see. We just finished doing this. Wow, see how my work is very, very technical inclined. If you see this kind of work for exam, you go just run first. You're like, God, what have I done? You saw like 4 section parts. But anyhow, let's see this one now. We're not going to work on many, just small from this. So let's say this stuff was sectioned in this manner. How is it going to look like from the half? Half should be how many? Total here to here is how many? That's 50. So half will be 25, abi? If you are measuring 25. Now I automatically know the positions of our measurement, the graduation. So that is why I say I don't really measure. When you are used to TD will be used to you. All of you will now be users interface. I don't know what I'm saying, sir. But shall you get the gist? If you don't get the gist, I don't know what you want to get again. So this is it. And you told, who should I use now? And you told Enifome, one of my favorite students that year. I miss some of my students too. So you told Enifome to look at this thing from this place. What should Enifome see? I know that Enifome can still remember this diagram. So Enifome looked at this stuff and it was like, okay. The first thing I can see is the total. Yes, it was not the initial graph. The total, which is this. I can see the total, which is this. Please, whenever I give you a particular sectioned part, all I need you to do is pause the video, attempt it, then watch the video to know if you got it correctly. It helps, please. Not watching it from beginning to the end, it will not be helping matters. You understand? Thank you very much. So, whenever we're doing initial graph, I need to do this one. So the supervisor was like, okay, I've sectioned this thing now. What can you see? And then we say, okay. That's true. When you take off this, I can see this edge. Yes, and the length from here to here is how many? 10 centimeter. I will now measure 10 here to here, 10. The 10 went down. Okay, also this one, I can see this one. Yes, that's true. From here to here, I'll do it down to this place. Now, the next thing again, Enifome will now realize is, there's a particular part again from here to here, actually, and it's 10 centimeter. So I'll have to do from here to here 10 centimeter downward. Everything is going down. Then you now realize that there is a hollow part in this diagram. There's a hollow part in this diagram, but the cutting plane will not affect this part actually, but there's a hollow part. So from here you cannot see this hollow part, But with the help of sectioning, we can now see this part, and the length from here to here is how many? 20. So this is 20, this is 10, and this is 20, right? This side, and this side. So then you'll be having this. Now let's see. And if we don't finally identify this thing, you're not like, MD, you not come your phone. MD, how far? I don't do this thing. No, what's next? What next? I say, why will you be asking me that kind of question? Remember, we have rough edges and smooth edges. Rough surface and smooth. Okay, that means that the rough surface is going to be represented by the diagonal. Okay, where is the rough surface? Okay, the rough surface is the part that is affected by the cut. Was this affected by the cut? No, to be plain. Was it affected by the cut? Yes, here will be rough. Down. Was this side affected? No, I'll leave it. Was it affected? Yes, I'll cut. Was this side affected? No. Was it affected? Yes. Okay, there's supposed to be another place here. Please, let's take notes. There's supposed to, this side now belongs to this. Then we have here. Let's take note. I've got to add that side. But if you knew, I'm happy for you. So at the end, this side is going to look like. Then all you have to do is now represent it here. Let's see if we can represent this one. It's very simple actually. I know some of you just skip this video. My God will judge you because you don't know and now. But it's very, very good. I'm happy you know it. So I have this here to here. So the height, the total is how many? 90. So here to here, 90. So I'm measuring 90 to this side. Now the height, 50 from our question. I hope you know, Shabi. Then this side, 250 from our question. Then I close up. Right? So this is going to be looking. So now I have to just fill up all this stuff. We know that here 10, 10, 20, 10, 20, 10, 10. So all I just have to do is fill it up. So we have 10, 10, 10, 10, 20, 10. So from here, I just have to draw. Please master your stuff before you start doing Oga accuracy. Please, I'm just using my eye gauge. I'm used to this already. I pray you get to that level one day. So I've gotten my stuff. So from there, let's identify the part affected. So when you do your measurements, just continue your movement. So I'm doing this. Please attend classes. My video can be very, very explanatory, but you cannot compare it with when you are seeing me face to face. You can blow me, you can question me, you can ask me why is this? Why will this be this? Why must this not be this? That kind of stuff. But when you're at home doing American person, I learn online. Does not help like that too. Not that it's not help. If you have opportunity to come, please come. If you have opportunity. So remember I told you that you can use centimeter. So I'm using centimeter. Yes, 10 millimeter base, so 1 centimeter. Some of us don't know how to calculate 1 centimeter. How many millimeter make 1 centimeter? Some of us don't know. Then we can get the height here to here, here to here. The height is 50, so that's 5 centimeter. And this, my friend, is so you can do your dimension anyhow and you achieve your goal. Thank you very much for watching. See you in our next video.